Okay, lesson 4.2, solve multi-step equations. Example 1, solve equations by collecting like terms. So it's going to start out pretty straightforward, and then we're going to get some more difficult ones as we move along. So the first one you have there is 3x plus 2 equals 2x minus 4. Now, the first thing that we want to do is collect like terms. So we typically want to group the terms that have a variable in them on one side, usually the left side. So we're going to kind of move this guy over using addition or subtraction. And then we're going to put the constant terms on the other side. Remember, a constant term is any term that doesn't have a variable, right? So here's a constant, here's a constant. Well, how am I going to move all my terms with a variable to the left? What do you think I should do? If I want to get all my x's on the left, can I just move this over here and, add 2x to this side?
No.
I can't do that, okay? In order to get rid of positive 2x on one side of the equation, I have to subtract 2x.
Yes.
If I do that to the right side, I have to do that to the left side,
No, what?
okay?
Oh, why would it be?
I have to do the same thing to both sides, because remember last lesson we drew all our scales and we said no matter what you do to the left, you have to do to the right, otherwise you'll tip the scale. So now what I'm left with, 3x minus 2x leaves me with 1x. This plus 2 is just going to come down. And over here on the right I had 2x minus 2x, so that's 0. So I don't need to write anything there, so I'm just left with minus 4.
But before we can group like terms.
Wait,
That's what we're doing. But now they're on...
Why do we have to do it this way?
They're on opposite sides of an equal sign. So everything on this side is equal to everything on this side. If I added 2x to this side, I'd get 5x. But if I did it to that side, I'd have to do it to this side, giving me 4x. Right? If I add 2x to one side, I have to do the same thing to the other side. That's not going to get rid of any x's on either side. It's just going to make more x's. It will still be an equation. It will still be true. And I could continue from there, but it doesn't help me isolate x. Okay, I want to get x by itself. So what I have to do, if I just want x's on one side, because that's how you solve something, right? You're going to end up with x equals something. That's a solution. I need to eliminate the x's on this side. Right now I have positive 2 x's, so I need to subtract 2 x's. If I do something on this side, I have to do the same thing on this side. Yes.
Why would we start on, like, say, the left side?
Could we move the variable and collect them on the right and subtract 3x from both sides? Yes, we could do that.
And I would get the same.
You'd get the exact same answer at the end of the day. Okay, we're going to try that in example C. We're going to do it 2 different ways, and you're going to find out sometimes it's good to start on the left, sometimes it's good to start on the right. Look what happens in this one. If we would have subtracted 3x from both sides, it's good, we would have cleared it out from here. But look what happens when you subtract 3x from here. What ends up happening? You get a negative x, which makes it one step more difficult, because now you have a negative x equals something, but you really want x equals something, which is not the same as negative x. It's the opposite. Okay? Good questions. We're going to carry on, and you'll get better at it as we go. We've moved the x's to the left. Now we just have x on the left, but we still need to isolate it. That means we actually want it to be the only thing on the left. So what's my next step?
You get rid of the 2.
Can I just cross it out, get rid of it?
But you have to minus.
I use my opposite operation. So right now it's adding 2, so I'm going to subtract 2. If I do it to the left side, finish my sentence, I have to do the same thing to the right side. If I do something to the left side of an equation, I have to do the same thing to the right side, otherwise I would tip the scale. Okay? If I subtracted 2 from this side and added 2 to this side, that would tip the scale big time. Yeah? Right. So I can't do that. I have to do the same thing on both sides. On the left, it leaves me with x. On the right, negative 4 minus 2 is negative 6. And it's helpful to box your final answer. Good. Now in this example, we did 2 steps. We first moved the x's to the one side by subtracting 2x from both sides, and then we dealt with our constant. in example B, we're going to see how we can actually do both of those steps at the same time. So you got 7 minus 2k equals 8 minus 5k. Now, it doesn't matter if you move it left or if you move it right. I am going to put the variable on the left. Okay, right away I can see that I'm going to have to add 5k. And if I add 5k to both sides, I'm going to be left with positive k over here. So that's helpful. If I added 2k to both sides, yeah, I'd get rid of the k's over here, but I'd still be left with negative 3k's. And it's a little bit more difficult to deal with negatives. So I'm going to move it left. If you can't see that right off the bat, it doesn't matter. You'll get the same answer. You'll just have one more little step. You'll have negative k equals something, and you'll have to get the opposite of both of those values. It's not hard, okay? But here we did it in 2 separate steps. Here I'm going to do it in the same step. I'm going to deal with the constant and the variable term in the same step. So if I'm going to put the k's on the left, I'm going to add 5k to both sides. And I'm going to put the constant on the right. So what do I need to do to this left side where I have positive 7? I need to subtract
Do
7.
you always have to put the letter on the left side? Or is it not really?
No, you do not always have to put the letter on the left side. It can go on the right side. Sometimes it's easier to do it one way or the other. Sometimes it's one more step to change it at the end. It's not a big deal. But for this one, we're doing it on the left. And I'm going to move the constant in the same step. So I just want k's on the left. That's all I want on the left is only k's. So that's why I'm moving my constant to the right. I have positive 7 on the left. I don't want it there. So I have to subtract 7. If I do that to the left, I have to do it to the right. Okay, so now we can kind of look at this and we know that 7 minus 7 is nothing. That's 0. Negative 2 plus 5 is going to leave us with 3k's. And now over here, we can think about your 5k's first. That's going to be 0, right? Right there, that's 0. And now we have 8 minus 7 is 1.
Oh, that's easy.
Can't you just
What's my next step? Because we're not quite done.
You do to the left, you gotta do to the right.
So I want to get k by itself. Right now it's being multiplied. Right, so I'm going to divide both sides by 3. Okay? Because this will cancel out getting k by itself. That was the goal, right? To get k by itself. So these guys cancel out on the left, leaving just k. And on the right, we have 1 divided by 3.
0.33.
Fractions are your friend. That answer is done. 1/3. Okay? This is not true. It doesn't equal 0.33. It equals approximately 0.33. It equals 0.33 bar. But this is an exact answer, and that's what we're looking for. Okay? Any questions on that example?
Since the equal sign, they're all equal, so you could hypothetically switch. It's not that important, but could you switch the sides? So could you, if you really wanted the x on the other side, could you just switch it around?
Absolutely. You could even get to this step, and that's often what happens. If you have k on the right, we always want to put our final answers with the variable on the left so that we can say k equals yada, yada, yada. So sometimes you'll get to here and it's backwards, and you might just write the next step backwards. You might just put this whole chunk on this side and this whole chunk on this side. It's the exact same. It's still the same statement. One expression equals the other expression. You haven't changed the expressions. You're still just saying that they're equal to each other, right? If A equals B, then B also equals A. Good. C we're going to do in 2 different ways. Okay, we're going to solve with it on the left, and then we're going to solve with it on the right. So we're starting with 5 minus 3m equals negative 2 minus 2m. And this time we're going to isolate the variable on the left. So, Ronnie, what are we going to do to get all of my m's on the left side?
Take 2m divided by 2m.
So right now, I'm just going to move this whole chunk. So right now I have negative 2m on the right. I'm going to add 2m to both sides.
Yeah. We do them left and
Okay?
right.
How am I gonna, Emily, how am I gonna move all my constant terms to the right side?
You're gonna do -5.
So I have positive 5. I'm gonna subtract 5.
Yep. And then on the other side, also the same.
I have to do the same on both sides. Now I can kind of think vertically. I can think down, and I can collect all my like terms. So this becomes nothing. That's 0. Negative 3m plus 2m.
Positive 1.
Negative M.
1.
Negative m.
Oh, we don't want that.
And over here, we've canceled out this guy. And we have negative 2 minus 5, which is negative 7. And check this next step out. We've done this before. We did it a little bit last time.
Positive M.
So when you get good at this, your brain can easily just go, oh, if negative m is negative 7, then m must be 7. Can we all see that logic?
Yeah.
Yeah.
Okay. What's really happening there mathematically is actually, remember that invisible coefficient, negative 1? We're actually dividing both sides by negative 1. When you divide something by negative 1, all you do is change the sign. You just get its opposite. Or you could multiply by negative 1. Get the same thing. Because 1 doesn't change the value, it just changes, the opposite changes the sign. Okay? That was putting the variable on the left. And can you see how we ended up with a negative, and that was kind of annoying, but just one more easy step. This one actually would have been easier, one step easier, if we had gathered the variables on the right.
I know the answer.
Jaden, what's the first step for solving it? If I'm going to put my variables on the right.
You take, you add 3 to.
No.
Yep, nope. Jaden is doing it. Thanks very much.
And you
Good
add-
job, Jaden. So it's negative 3m, so I'm going to add 3m. Am I done that step?
No, then you add 3M to the other
I
side.
also have to do it to this side to keep my balance scale even.
And then you add 2 to that side, and then you add 2 to the other side.
Perfect. And now right off the bat, on the right side, I'm going to get this is 0. Negative 2m plus 3m is positive m. And over here, this is 0. 5 plus 2 is 7. Now, when you're doing your homework, this is good enough, I guess, to leave it like that. Typically, you would rewrite it and say m equals 7. Same thing, but just it's proper way to write it, easy to see, better form. Okay? Pretty straightforward. You guys are doing well. If you do it to one side, have to do it to the other side. Okay. Example 2. Solving equations with brackets. So this time we're solving 5, and then it's being multiplied by the group y minus 3. And then we're minusing the whole group of y minus 2, and it's set equal to 19. Now we're going to solve this. What does it mean to solve?
To figure out what it is.
What is?
Find the answer of the equation.
The root of the answer.
So what is the root?
The equation.
Answer.
19.
The dividend.
The problem.
That is the root.
We want to find the value of the variable. Okay? Could this y be different than this y?
Yes.
Yes.
Yes,
No,
it can.
it's
the
no.
same
No.
one. It's possible.
No, it's not
No, if
possible.
they're different, they can be
Stop.
the same order.
One letter can only be one thing in a given equation. Okay? Can only be one thing. Y cannot be 7 and 2. Can't happen. Okay? Y is Y. It's just one thing. It's if it's 2, it's 2. If it's 4, it's 4. Okay, so we're figuring out what Y is. Now, why is this one a little bit more difficult?
Get it? Why?
What makes this one a little bit more difficult?
Because we only have one number on the equal on the other
So
side.
you can't keep
Okay,
them
there's
up.
only one number over there.
You can't keep
And we
taking
have,
away
uh,
from 19. I guess you could actually.
One of the things that we like to do is collect like terms. Can I collect these y's right now?
Yes.
No, because
I-
in the same
No, you
sentence,
can
then
like
you
you
go
can
on
collect
balance.
I can't-
between the two.
I can't collect them because this guy is grouped. This isn't just y, it's y minus 2. He's
You gotta-
stuck together.
You gotta get the bracket,
Okay.
so
Oh, I have to remove my brackets first. Do you have a strategy for removing brackets?
You just move them away.
No.
No. You
you thought.
You.
you can put this little note. Remove brackets by applying. Do you have a property that allows you to?
Multiplicate. No.
It's special form of multiplication.
It's called division.
It starts with D.
Division.
Dividing. Disability. Distracting.
Distorting.
Distributing.
The distributive property.
Disability.
Okay, make sure you write that, please. So, distributive property says that since this whole group is being multiplied by 5, I can write an equivalent expression by multiplying 5 by each of the terms in the binomial. Now, we're going to do that, but I want to look at this one as well. What happens to this negative sign? How do we distribute? How do we get rid of the brackets on this side?
Because the negative is actually a 1.
There's an invisible 1 here. So this negative sign is going to get distributed to the y and to the negative 2. Okay? So here we go. 5 times y is?
5y.
5y. 5 times negative 3?
Negative 15.
Negative 1 times y?
Negative y.
Negative 1 times negative 2?
Negative 2.
Careful.
No.
Positive 2.
Positive 2.
Right there is half a point. Okay? And the right side just stays the same. Now what can I do?
Now you can group.
Collect
Like
like
by
terms.
grouping.
Collect. Write your step there. Collect like terms. Well, they're already all on the same side. So I don't need to, add and subtract all the way across and both sides and all that. I already have this whole side. I can just collect my like terms in this expression. So how many y's do we have on the left side of the equal sign? 5y minus y.
4y.
We have 4 y's. And the constant is negative 15 plus 2.
Negative.
We still have 19 on the right side. Now what do we do?
Now you can't do. Oh yeah, you can.
Now you multiply.
Now we want to isolate y. Okay, now we want to isolate y.
Have to divide.
So you got.
Isolate y. So you're right, we're eventually going to divide by 4, but that's not first. What happens first?
Don't you?
No, you gotta get rid of the 13.
Isolate y by adding 13. What am I going to say? To
Both sides.
both sides. All right, that looks like this. Plus 13 here, plus 13 here.
How come you can't just do this with everything?
That gives us 4y equals 19 plus 13 is 32. And
Maybe
the,
why divide by 4.
No, it's not.
now we divide
Yeah.
both sides by 4.
Oh.
Divide by 4, divide by 4, and y equals. So we're on page 9, top of page 9. Olivia, today's lesson is the same as yesterday's lesson, except there's multiple steps in the process. I'm sure you'll understand if you look at someone's notes afterward.
Yes.
But here we go, page 9, solve and check. So this is the same kind of question as A was. In A, all we had to do was solve, but this time after we get our value of x, we're going to check to see if we got the right value. Okay, and we'll show how to do that. We did it yesterday, but you'll see. So we've got B here, and it is 2x minus 3 equals negative 3x plus 5 minus 6. Okay, there's a lot going on there. And right now, my x's are on opposite sides. So at some point, I'm going to have to do my, subtract whatever from both sides. But I can't do that yet. Because here, x is trapped in a group with positive 5. And here, x is trapped in a group with negative 3. So what can I do?
Oh, use the distributive property.
Good. Pay attention, guys. One of the most important things that you will learn in math it's sometimes so hard to see, okay, we're going to get from this is all going to boil down to just x equals one number. But it's hard to see how to do that. So one of the best things you can do when you get to a challenging math problem isn't say, okay, how do I solve this thing? It's, what could I possibly do? Right now, you literally can't do anything. There's only one other thing other than the distributive property that you could do. You could add 6 to both sides, right? This 6 is just a free-flying constant way out here on the right. You could add 6 to both sides, and all that would do is move that number over here. It doesn't help you at all. So that's something you could do. The only other thing that you could possibly do in this problem is distribute.
Genius. Absolute genius.
That's mean.
So, can someone please distribute 2 times x minus 3? Jacob, we get 2x. Can you finish it off?
And would that be -6?
-6 equals, and someone else for the next distribution?
Negative 3x.
-3x. Finish it off.
And negative 15.
Yep. And then we keep this -6 out there. Good job. Now what can we do? Now what can we do?
Ooh,
Group like terms.
Yeah, so at this point, guys,
Distributed twice.
at this point, I would group like terms over here just to simplify this step. We won't be done, but we can simplify this step. So I'll rewrite what we have on the left. I can't group those any better. -3x is still here on the right, but now I have -15 minus 6, which is -21. Okay? Good. What's my next goal?
Get rid of the x. Or like,
Get all my x's on one side and the constant on the other side, right? So which side I can see here, I'm going to be adding 3x. So it's probably wise to bring my variable to the left, right? So let's do that. We're going to add 3x to both sides. And in the same step, what could we do? If I'm bringing my x's to the left, I want to bring my constants to the right. So how am I going to lose this guy?
You can plus 6.
Add 6 to both sides. Well, here's what that looks like. We said we were going to add 3x to both sides. So I have to do the same to both sides. And I'm going to add 6 to both sides. Which over here is going to give us 5x. And over here, -21 plus 6. So remember, I'm kind of going, we had a rule for this when we were working with just integers by themselves. This is like 21 minus 6, which is 15. And then which sign do I use?
Negative.
The sign of the bigger number. So it's -15. And the last step here,
Divide by
divide
5.
by 5.
divide both sides by 5. Yeah, we're getting this, eh? Final answer,
-3.
x equals -3 with a box. Good. Now, we were asked to check it. So remember when we were checking things, hopefully you have some space to do this off to the left. Yep, we have a left side,
Left side and right side.
and the left side is 2 times x minus 3, and we have the right side. The right side is -3 x plus 5 and minus 6. Now, in order to determine whether or not we've done this right, whether or not x equals -3 really is a solution to the problem, all I need to do is substitute -3 wherever I see an x. Okay? So watch what happens. Watch first and then copy it. In our bracket, we just have -3 minus 3. That's the left side. Okay?
Wait, how?
All we had to do is put -3 wherever we see an x. So instead of x, I'm writing -3. Okay?
Okay.
Now we can finish that out all the way down to the bottom.
Oh,
I can
yes.
group these guys together in there. -3 minus 3 is -6. 2 times -6 is -12. So my left side is -12. If I get the same on my right side, then x equals -3 is the solution. Okay, it is the root of the equation. If I don't, then we have to go back and try again because we did it wrong. Okay, so here we go. Everywhere I see an x, I'm going to put in -3. So I have -3 plus 5 in the bracket. And on the outside, I still have -6. Now inside the brackets, I can actually do this work. I don't need to distribute. I know that -3 plus 5 is +2. And we have -6 on the outside. -3 times 2 is -6. -6 minus 6 is -12. Left side equals right side. If we get left side equals right side, we know we did it correctly. And x minus 3, x equals -3 is the root. Any questions on anything you just saw?
For every question that says check and solve, we have to do both steps.
For every section that says check, solve, and check, yes, you have to do this. Okay? Unless Mr. V cuts you some slack and I say, oh, check 3 of them. Which could happen. If you write my secretary a letter requesting such. No.
Who is the secretary?
And you have to get the letter in yesterday, so sorry. Missed the deadline.
Joke's on you because I already wrote one.
Next. Example 3. Use an equation. It's pretty good.
So funny.
Okay. Example 3. We're going to use the knowledge that we just built today, and we're going to develop an equation. It's going to help us model a geometric relationship. What's geometry? Shapes. Okay? So we're going to have some kind of shape. We're going to have angles. The angles are going to add up or subtract or whatever, and we're going to figure out what they all are. Okay? So here we go. A triangle. Try to draw this, by the way. Try to draw this before I do. A triangle has angle measurements that are related in this way. So this is how the triangle's angles relate to each other. How many angles are there? 3. There's a good step. The largest angle is triple the smallest angle. And the middle angle is double the smallest angle. So you have a smallest angle, you have a middle angle, and a largest angle. So my strategy would be, it doesn't really matter what your triangle looks like, but draw a small angle. And then draw an angle that's twice as big as that angle.
Like that.
And the third angle will inevitably be 3 times as big.
Oh my god.
Okay? So that's,
Quadruple.
I'm going to just redraw it a little bit bigger. Okay. So we have this triangle, and we have its angles, but we are going to need to find the measures of the angles. So there's a couple of pieces of knowledge that we need. Well, one piece of knowledge that we need, and one thing that we still need to do to this triangle. Right now, none of my angles are named, and none of them have measurements, and none of them have actually really been related to each other. Should I introduce a variable?
Yes, you should.
No.
What should my variable be?
X. 7.
Let x be what?
The largest angle.
No, but the
Smallest.
smallest.
Why the smallest?
Because it just looks like an
The medium.
Because that's the one that you need to.
That's the one that we're relating to, right? And because if I did it being the biggest, then to get the smallest ones, I'd have to use division, right? I'd have to say the smallest one is x divided by 3. That's annoying. Why don't I just say the smallest one is x? Then the biggest one is 3x, and the medium one is 2x. Does that make sense? Let x be
Yes, that makes sense.
the measure of the smallest angle. Okay? The other angles are, what's the measure of the other angles?
2x and 3x.
2x and 3x. Well, go ahead and put them on your triangle in the right spot. And what is our goal?
To find out what x is.
Yep, that's not going to be our final answer, but that's definitely a step along the way. What's our final goal?
Just find the angles.
Find out all the angles. So in order to do that, we're going to find out what x is. Well, what piece of information are we still missing?
What x is. What the angles are.
What do we need to remember?
They all equal 180.
Yeah, recall angle A plus angle B plus angle C equals 180 degrees. So that means x plus 2x plus 3x equals 180 degrees. Well, now it looks pretty familiar, right? This is a pretty easy algebra problem, really. What's our next step? Yeah, Mads?
So divide 180 into 3, and then,
That's 60.
oh wait.
That's
No,
different.
Into 6.
Okay, you.
And then take the 3x, and then have 3 parts of that, divide it into 6, and use that for 3x, then 2 parts of that 6 for 2x, and then the 1 for 1.
Good. So that's exactly what's going to happen, but algebraically we can do it more efficiently. So what am I going to actually write? What am I going to do to these numbers?
Oh, cross them out.
Cross them
Do you see any
Oh, no, yeah, they're-
like terms?
Yeah, 2x
They're
and
all
3x.
like terms.
Yeah, but
Oh,
isn't
just
there-
that has an
They're all like
invisible
terms.
one.
How many x's do we have?
6.
6x.
Okay.
Oh.
1x plus 2x plus 3x. That's easy. I can add those. It's just collecting like terms. 6x equals 180 degrees. Next step,
Divide by 6.
divide both sides by 6 to get x by itself. X equals 30 degrees. Am I done?
No.
No.
Not done. Okay, so we do have one of the angles. Now we need to still find out the 2x angle and the 3x angle. That's easy. Wherever you see x, you sub in 30. 2 times 30 is 60. 60 degrees we'll write at the end. And 3 times 30, 90 degrees. Therefore,
Your triangle is wrong.
X equals 30.
the 3 angles are 30 degrees, 60 degrees, and 90 degrees.
Do we have a test on Friday?
Okay. To solve an equation, guys, when you're going through your homework, keep these examples open because there is a specific order that we did things in. And if you do it in that order every time, you'll get it right every time.
Specific?
Okay? So to solve an equation involving multiple terms, collect variable terms on one side, constant terms on the other. Make sense? Always do the same thing to both sides. And then you can check your answer by subbing in your solution to both parts of the equation. If they come out being equal, then statement is true. You got it right. All right, your practice problems are at the bottom of page 9. If you're not done the practice problems from yesterday, do those first. And by tomorrow, you should be done all of them. Okay? You should be done to the bottom of page 9 by tomorrow.
Jenna.